Hello everyone. So today we are going to solve a level order traversal of the binary tree. And this is our sixth video of this playlist. I have covered all these basic problems. If you have not seen, please watch those videos. And let's start. This problem level order traversal will be very useful for the further problems. So I would highly recommend you first to go through this video so that it will be you will understood the approach and pattern to solve the further problems. Okay, so what we have given is we have given the root of binary tree and we need to return the level order traversal of this binary tree. So level order traversal means like you have to traverse the binary tree in the level one is the first level, two three is the second level. So you have to return the one two three. Okay. Similarly, in this 10 is at the first level, 20 30 is at the second level, 40 50 is at the third level. So you have to return the 10 20 30 40 50. So let's go to whiteboard and see how it will look like. So consider I have this same example 10 and consider 20 and consider here is 30, consider here is 50. Okay. So this is the first level. Okay, consider this is a level 0, this is level 1, this is level 2. So you have to return the in the same order. Like in the 0 level, the elements are 10. In the first level, you have to start from the left side. So elements are 20, 30. So you have to return 20 and 30. And in the last level, the elements are 50. So 10, 20, 30, and 50. You have to return this. Yeah, this can be extended to further, like you have to return only the elements that are present at the particular level, like consider level 1. So you have to present only the elements in the 20 30, or you have to return the elements of the particular level in the reverse order. In that case, you have to return 30 comma 20. So like this, it can be extendable to multiple programs. And we are going to see this, like how you can approach that. So consider we are going to use the BFS approach. BFS is because we require the breadth first, right? Because we are going into this particular node and we are going to trace these particular nodes in the breadth first. So consider I have some data structure. I will start from the root node. Always in the binary tree, you are going to start from the root level node and store this particular 10, okay, the root level node, and see if there is a what are the values present at the left or right side. Okay. So consider like your left is 20, so you will store at the 20 and your the right value is the 30. Okay, you will store this. So initially you have stored this 10 and now you will store this 10 in the consider in the array list that you have to return. And you have seen this 20, so you will pop out this 20, check if there is left is not present, right is present, so you will take the 50. And okay, so there is nothing else, so you will just store 20 in the array list. See 30, if 30 is present, like there is no left and right for 30, so you will just pop out and add into the array list. And see for 50, there is no left and right, so you will just take it out and write the 50. So like this you will go into this. Why we are doing the left and right? So that for every node we are first going to store the left and right to trace them, and then further their left and right, their children, something like that. Okay, so you have to first think about, like consider like this. You are first see the grandparent, then their children's, then their children's. Like this we are going to trace. And so okay, in the same manner we will write this code. So consider like I have array list. I will create this array list as result. And what I'm going to do is I will first check the base cases, that are if my root node is itself is null, then I don't, then I can return the empty array list. Or then I will check the further cases. Okay. And consider for this data structure, I will use a queue because in BFS, we are going to use the queue to store the data for the first in first out. And we will store the node in this manner. So we will first store the root node into this, and we will check like till queue is not empty, we are going to pop out these elements. And what we will check is we will take the node that is current node, and we will take this element and we will just append to our array list this data that whatever we have. And we will check if my current node dot left is not equal to null. It means like there is a current node, left node is present. So I will just add into my queue that current node dot left node, and same for the right. If right node is not equal to null, then I will add queue dot add this thing. This extra check I am checking for the null constant. If you are not checking it, you will end up in adding the null values. So you have to make sure like how you are going to handle this. So explicitly I am validating if that is particular not null node, then itself I am adding this. Okay. You are considering this as a like black box function only level order, but we are going to use the BFS here. Okay. So let's try to run this program. Okay. We have to return the result array list. So let's try to submit it. Yeah, it is working fine. So you have to be understood like how you are approaching this problem, and this is very helpful for the further problems. Like we are going to see the left view, height of the binary tree, and right view. So this problem is very helpful. If you understood this approach, please like and subscribe my channel so that you will be updated with the other videos. I'm going to complete this playlist of the tree as soon as possible. So and thank you for watching.